All right.
The second speaker is Zhang Liang. I will introduce him. Zhang Liang will present the paper entitled Energy Saving Methods Adoption Research for Typical Building Models on the requirements of 65 energy saving in different climate zones of China. That's authored and co-authored by Xiaofen and Zhang Liang. Zhang Liang is the graduate student from School of Mechanical Engineering of Peng University. His research interests in space and air management in the field simulation and free building technology. Welcome, please.
Thank you, Chair. Good afternoon, ladies and gentlemen. My name is Zhang Liang from Tongji University. I'm very glad to be here to give this presentation for you. What I'm going to talk about is my work report on establishment of typical building models in China and a research of adaptability of energy-saving technologies and the standard of 65% energy saving of buildings. Next, I will show you the introduction, the background introduction. In 2006, the decision of State Department about improving energy saving work is published in China, which requires that 65% energy saving standard should be first carried out in municipalities and regions where condition permits in China. 65% energy 65% energy saving means that we save 65% energy comparing to the standard of 1980 to 1981 in China. Today, most of our buildings in China have already reached the 50% energy saving standard. That is to say, we need extra 30% to reach the 65% energy saving standard. But here comes the question. Before we're talking about saving 30% energy, we have to know the baseline first. What's the baseline of our energy consumption? Typical building models can provide us with these baselines of energy consumption. A typical building model has to be able to reflect architecture features and real-world usage of buildings, and generally represent a certain type of building. A typical building model can provide us with a platform that can be used to study the effect of energy consumption. It is worth mentioning that the climate region of hot summer and cold winter region is studied in this paper, in which climate Shanghai is in. What's more, the software Energy Plus is used in this paper. Energy Plus is a whole building energy simulation program and is widely used in the world, and I believe that most of you are very familiar with. So that's all for the background introduction. Next, I will show you the contents of my paper. As is listed in the PPT, the contents of my paper can be summarized in 3 parts. First, baseline models of 6 types of buildings will be established. Then, various combinations of energy-saving technologies will be applied to baseline models. Finally, we will test whether present mature techniques can achieve the requirements of 65% energy standard. Obviously, that the step 3 is based on step 2, and step 2 is based on step 1, and that's their logical relationship. The 3 are equally important, and I will start with the first one, model establishment. Supported by CBECS, the typical building models in the United States are very mature and have experienced 3 versions. While in China, typical building models are still immature. As a result, it is very meaningful to research on the typical building models in China. We mainly refer to the national building standard and local building standard, such as public building energy efficiency design specifications and the thermal design specifications for civil buildings, to collect the information and the data we need in this paper. If we cannot find the data and information we need, we can find them in the literature research data as supplement, such as the annual report on Chinese building energy efficiency by Tsinghua University. So next, I will show you the process of building establishment. Data collection. Comprehensive data will be collected of the model of high-rise office building, multi-story office building, multi-story residential building, high-rise residential building, and shopping mall, and hotel. These data include gross floor area, shape coefficient, number of floors, area ratio of window to wall, building orientation, story height, building functional partition, air conditioning system, lighting power density, equipment power density, and occupant density. So next work is to build geometric model in Energy Plus. Then we use IDE editor in Energy Plus to finish specific modeling. Then we use EP Launch to run the debugger and get preliminary results. Finally, we calibrate the result. Non-air conditioning parameters will be adjusted and enables the simulation value within an acceptable error, comparing to the measured value, just shown in this chart. So the model establishment complete. Then we will move to the next step, applying various combinations of energy-saving technologies to baseline models. In this paper, mature energy-saving optimization technologies include building envelope optimization, air conditioning delivery system optimization, cold and heat sources optimization, and the lighting optimization. And these 4 categories of optimization technologies will be used in combination. And then I will show you a simple example. In this table, we are discussing the combination use of energy-saving technologies in building envelope and lighting, and their energy-saving effects in multi-story office buildings. Different combination of technologies will bring to different energy consumption results, as can be seen in the second column as the initial value of 50% energy saving standard. Then we add XPS exterior wall, XPS roof, and low-E glass to the initial model to see how the energy changes. After that, we gradually add other technologies like daylighting, dynamic concentration, and common external shading, and compare their effect of their energy saving and economy. Just as seen in this case, we can see that in the fifth column, the XPS exterior roof plus XPS roof, or plus low-E glass plus daylighting plus dynamic concentration achieves the best effect of energy consumption. That's another example of the energy consumption effect of different water systems in high-rise office buildings. And there's, as is shown in the table, there are 2 kinds of water systems, and the right one with a larger temperature difference and a smaller flow rate. And we can see in the values below, and it shows that this kind of technology are perform better than this But there is a question is that the effect is not very obvious. So maybe we will not use this kind of technology. So similar work can be done in the other 5 typical building models. And the following table shows the results of optimal application of mature technologies in 6 buildings. The results of application effects of present mature techniques in 6 typical buildings. It can be seen that the high-rise office building, a shopping mall, and hotel have achieved energy saving effect of more than 30%. That means in this building, with the application of mature techniques, can reach the requirement of 65% energy standard in China. While the multi-story office building, the multi-story residential building, and high-rise residential building, and their energy saving effect is very little, and below 30%. That means that they do not reach the requirement of 65% energy saving standard. Also, we can observe from this table that the optimization of building envelope is the most widely used technologies and have a very good effect of energy saving. So from the analysis, we can draw the conclusion. First one, the building envelope is the most potential category of energy saving technologies in this paper. And the high-rise office building, shopping mall, and hotel have more energy saving potential with the application of mature technologies, while the other 3 kind of typical building models did not achieve so much very good effect of energy saving. So these 2 conclusions can guide the future work of our energy conservation work. And we can widely apply the high-rise office, apply the mature technologies in high-rise office building, shopping mall, and hotel, and to reach the standard of 65% energy saving. But to the building type of multi-story office building, the high-rise residential building, and they are not achieve very good effect of mature techniques. So we can develop or invent some new technologies that is suitable to these kind of buildings to achieve the 65% energy saving standard. So that's all for my presentation. Thank you.